to do is just do a very quick review of the concept we were discussing in class yesterday, and then move on to where I would go next. Basically, what we're doing is we're reviewing the concept of fractions, okay? And I've said a few times in class that this seems really elementary, but it's not. There are many, 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 many adults who don't understand this concept of what it really means to deal with fractions. We know what to do with a problem like this, for example, algebraically. We've been taught to basically add across the top if the denominators are the same, right? In this case, they are, so we can just add across the top, and we know algebraically that would mean that we have 10 halves, and then when we simplify, the way we've been taught to simplify, we know that equals 5. But what I was trying to do is get you to visualize what does it really mean to add 9 halves plus another half. Like, what is that? And so we talked about how there's a whole circle. If we consider this, if we do, it doesn't have to be a circle, it can be some other shape, but any shape you can visualize best in your head. If we talk about that shape being our whole for this particular problem, which in this case I'll just say it's a circle, then half of a circle would be this, right? If we just kind of visualize this circle being split in half, okay? So here's my crude drawing of a half of a circle. And if we want to actually draw out what does it mean to have 9 halves, okay, so we're starting with 9 halves. Draw them out over here. Then I would draw 9 of these, 9 halves. So there's one. I have 1 half, 2 halves. There's 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves. And then if I'm going to add another half, what I'm going to do, some of you change the rotation of the half just to show that that was a different half. I'm just going to change colors. I'm going to go like this, because it's still a half, right? But I'm adding in a new half into this bunch of 9 halves, because that's what the problem is asking me to do. So now, if I were to count all these up, what I would have is, let's do the color. I would have 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, and now I have 10 halves when I add in my half to the problem. And when I have 10 halves, that's the same thing as this right here. When I solve, oops, sorry, why is it doing that? I'm suddenly not wanting to draw. I want to circle this. Ah! Oh my gosh, it's like suddenly not functioning. There we go. 10 halves is what I have here. I counted 10 halves that I drew out. And then again, if I were to simplify those, I would get 5. But how you think about that in our representation is when we simplify, what we're doing is we're joining 2 halves together to see 1. And I'm going to do this in another color just so we can keep track of this. If I have this half and this half put together, I would get 1 whole. And that's why I'm writing 1, okay? And if I were to do the same thing here, I would get another whole. And if I were to do the same thing here, I would get another whole. And if I were to do the same thing here again, I get another whole. And then now, I've added another half to my problem because that's what it said to do, is add a half. Now I can join these 2 halves and get another whole. And if I were to count up all my wholes, I would end up with 1 whole, 2 whole, 3 whole, 4 whole, and then 5 whole circles, which is indeed our answer when we solved it algebraically. Okay, so that is just a review. So now I'm going to clear the screen, and I like it with a black background, so I'm going to do that. Okay, and then so then after we did 9 halves plus 1 half, and we talked about what does it mean to subtract fractions. Whoops. It's not writing. There we go. So we chose this problem. And you know what? I know from testing this out, when I use this thickness, you don't see it very well in the video, so I'm going to do a zoom. Uh-oh, that's too much of a zoom. Let's do an undo. Sorry, I'm going to have to undo this a few times. Alright, let's just do new, it's easier. Alright, so let's get that black background back. There we are. I'm going to do a pin. I'm going to do a zoom to large size, and then I'm going to start writing. Okay, so now, the next problem we did in class was 5 halves minus 1 half. And I wanted you to think about this problem the same way we thought about the problem of 9 halves plus a half. So basically, if we're going to, let's just do a new shape this time, just to mix it up. Instead of a circle, we're now going to say our whole for this problem is a square or a rectangle, or a very awkward rectangle. And if that is going to be our whole, then a half of our whole would be one of these halves, right? So I'm going to say that's a half. So basically, for 5 halves, what this problem means is I'm just going to draw 5 halves. There's one half, there's another half, there's another half, and there's my fourth one, and here's my fifth one. Okay? Now I have 5 halves. But I'm going to subtract a half. So to subtract a half, as long as this pen will work, I'm going to have to take one away. So I'm going to take this away. That's one of my halves I'm taking away. What I have left are 4 halves. Okay, here's 1, here's 2, here's 3, and here's 4. So there's my 4 halves. And again, if you think about it like we did in the last problem where we joined the circles to make a whole, we can join these half rectangles to make a whole. And when I join them, I end up having 2 whole rectangles. So basically, when I first solved this problem, I'm going to bring the answer down here, we ended up with 4 halves. And then when we simplified by joining all our halves together to figure out how many wholes we have, we ended up with 2 whole rectangles. Okay? And if you solve this algebraically, just like we've been taught, where you add or subtract across the top, you end up with, I'll do some different colors so we can see, you end up with 4, and then we keep the denominator the same, we end up with 2, and that's the same thing we have right here, right? And then if we simplify this algebraically, we'll end up with 2, and that's the same thing we have right here, okay? So I think we were clear on that in class. That's about as far as we got with this concept. But then I wanted to start working with multiplying fractions. Okay, so let's clear the screen again. And by the way, I know that when I'm talking in this video, the sound comes before the visual. So if you notice that I'm saying something before I point to it, it's just because the video capture software is a little slow.